there's approximately 5-degree angle, which I'm now going to go around with this. What happens to the magnet, sorry, the moon, when we take it around the equator on the ecliptical? Now, we've seen what happens when we go over the poles and we get a continuous rotation at the pole, and it cartwheels. What will it do now? Hopefully we can see. I don't think a lot happened. Let's try and lower this down if I can. It's not a bit better because no, we're not going down far enough. Small, so we'll go past it. It's too hard. See, things are a lot more difficult than you would believe to get a real bloody experiment going. See, I'm not happy because we are not coming up high enough. And that kind of couple of seconds. Yeah, not easy. What you can see, there is definitely no rotation. There's a very slight one. That's facing upwards. Now it's facing that little black line right there. When we go up here, it's more face on. Turning that way, turning counterclockwise. Now it's come a bit clockwise. So yeah, as you go round the equator, as I said before, it does that, and that's because it passes from this side of the magnet to that. I'm going to try and draw it now. What I believe is happening. So, this in shot. So you got your Earth. So you got your magnetic field, which actually does that for the top, and then this one comes out and scrolls into that, and scrolls into that, and this actually creates flux tubes, is what they called them on the internet. They discovered flux tubes here. Now, I'd already done this video years ago, which proved that I knew that this magnetic field met at the inertial line. That's where we get storms and, you know, all that. That's the equatorial storms, is because the magnetic field is linked there from either side. Okay, but now, because the magnetic field does that, but then you've got the opposite field doing this. So this would be, let's say, clockwise, counterclockwise, and this one is clockwise, and this one is counterclockwise. So this and this and this and this are on the same side, clockwise and counterclockwise, and on this side it's inverted and reflected, so we've got clockwise and counterclockwise. So coming out of here is another field, impulsion V to expulsion A. Now, as the moon, which is way, let's just make this a little flatter, so this is the other bit of the magnetic field, which is out this way. And if I carry that over, it would be doing that, and if I carry that over, it would be doing that. So this is on both sides of the planet. But the moon is travelling here at 5 degrees inclination. Don't know if that's the way you spell it. 5 degree inclination moon orbit. So because we just saw on the magnet magnetised object, which was what this isn't generating its own magnetic field. That's been checked. It's got a very low one, but it's not doing anything. And it's on our orbit, which means it's attached. So this is counterclockwise, and this is clockwise. Now, as this spins around in front and behind the planet, it touches the clockwise, and it touches the counterclockwise, touches the bottom of this side here. And so what it does is, I believe that this side, I believe that the moon is opposite. It's opposite to this field. So as it passes it, it gets pushed in a counterclockwise direction. So that should be, we'll leave it at that. This is clockwise, and it turns it counterclockwise as if it's pushing against it. The same happens when it's down here. So what it does is it gives it a slight rocking motion. This is how I've talked. And the moon goes across the sky, and it actually does that. This can be seen on plenty of NASA videos and amateur videos and all that sort of thing. Now the moon, as it comes across, there is a slight wobble. As you go as high in when it's in the north and when it's in the south, they end up with a little wobble. Some people attribute this to other things, but it's the push and pull of the Earth pulling it, and it changing from clockwise to counterclockwise, and it's kind of grabbing it like that, and it pulls it this way and it pulls it that way. It's difficult to explain a picture in your head, so that's why I drew this. So that's the magnetic fields. The pen's starting to stop working. That's the moon orbit, comes around here, and I believe it brushes the north field there, and I believe it brushes the south field there. And so where it touches these, it's like a opposite polarity, and so it pushes it away until it comes off it. And then when it passes this point, which is the exact midway point, this stops being pushed one way, and then this side starts pushing it when it hits this field over here. So that'll push it that way, that'll push it that way. If I'm just thinking off the top of my head, yeah, that's about right. So yeah, I think that's what's happening. It's hitting the opposite fields, and so it's giving it a push on this side because it's giving it a push. You see, the moon isn't a magnet. It's just an electrified object from the Earth which turned it into a magnetic object. There isn't any such thing as a magnet. This is giving off a magnetic field because energy is hitting it and sending it back out so I can see it. This is generating a magnetic field. It is not a magnet. But if you place a really powerful energy object next to this, it will attract it. I've shown this on video. Things that people think are not magnetic are magnetic. Everything is magnetic and electrical. Just this has a low electrical content, that has a really high electrical content. The moon has a low electrical content, the Earth has a high electrical content. That's why we have a magnetic field, but even our power is coming from the sun, and its power is coming from the centre of the galaxy. Energy is transported to the sun via a Birkeland current. Energy is transferred to the Earth via a Birkeland current, and energy is transferred to the moon via a Birkeland current. This isn't a magnet, it's been magnetised by the sun. The sun isn't a magnet because it's been magnetised by whatever's in the centre of the galaxy. Whatever's in the centre of the galaxy isn't a magnet. Do you see where I'm going with this? There isn't any such thing as a magnet because everything on this page generates a magnetic field. Everything within my graph generates a magnetic field or an electrical field. I do hope that's an education in what a magnet is. No such thing as a magnet. Theoria apophasis, Ken Wheeler's closer with that. He says it's like a capacitor, which it is. It's closer to being a capacitor than it is to being a magnet, but capacitors don't do what magnets do, sort of, so to speak. So there's no such thing as a magnet, and there's no such thing as a capacitor. There's just matter that absorbs energy and then sends a wave out, which creates a pulse, which is determined as a heartbeat. Thanks very much. My name is Lee. I follow the Christ, and I like to explain things if I can. God never showed me this, but he showed me the understanding to work it out due to how magnetic fields are. And there's always an inertial line separating, and if this is going to swing around both of them, it's going to wobble on either side, but it won't have a cartwheel, not unless you send it over the poles, and then it's going to rotate counterclockwise, not clockwise. So thank you for joining me in these scientific experiments with the apparatus needed to show it to you. Thanks a lot. Bye.